properties of rational expressions and functions. Our objectives are going to be dealing with finding the domain, reducing rational expressions, and evaluating, and some real life examples at the end. So a rational expression, the word ratio is in this. So this first 5 letters is the word ratio. That just means there's a fraction. So an example would be something like 3x over x plus 1 would be considered a rational expression, or 4 over x squared minus 9, that would be considered another rational expression. Any of those that have a fraction or a ratio with a term on the top and a term on the bottom are considered rational expressions. So it says remember denominators of these rational expressions. So the denominator is the bottom. So this bottom and this bottom right here cannot be 0. So that's what you want to write here, because that's going to go right into our domain issue. So domain are your possible inputs. And in this case, it's typically we're talking about x values. So that's our domain. So what are our possible inputs? So the only thing that we really need to worry about is what makes the bottom equal to 0 and not include that in our domain. So the steps to finding the domain is to first set the denominator equal to 0 and solve. So, equal. Didn't mean to do that. Equal. So if we set this denominator to the right side on this example, 2x squared minus 2 equals 0, we would pull out a GCF of a 2, and then we can factor this x squared minus 1 into the difference of 2 squares. Anything that is its own factor you can make equal to 0 now, so that'd be 2 equals 0, x plus 1 equals 0, x minus 1 equals 0. And then from here, this 2 equals 0 does not make sense because there's no variable attached to it. These other ones will give you x equals negative 1 and x equals 1. So those are going to be the two numbers that if you plug them in, you're going to get a 0 on the bottom. Okay, so if you plugged in a negative 1, you get a 0. Plugged in a positive 1, you get a 0. The second thing you need to do now is realize what I just said. You just found what the denominator can't be. So that means that your denominator can be anything except for those two, right? So in order to write that, if we create a number line with shading on it, our number line would have negative 1 and 1. And if you remember back in middle school, I think you guys used open circles. In freshman year, you guys might have used parentheses. That's just saying that your shading now can be anything to the left forever, anything in the middle, anything to the right. But the one or the two numbers that you can't have are negative 1 and 1 as your answers. So step 4 is to write, All right, we're going to write our answer in interval notation. So if we just copy this number line, that goes from negative infinity to positive infinity. So our domain would be negative infinity to negative 1. In geometry, you learn this U for union. Negative 1 to 1. Another U, 1 to infinity. So that means that your domain can be any number on the number line, except for the 2 that you found would give you a 0 on the bottom. So that was our whole piece right up here. it says, remember, denominators can't be 0, because if you get a 0 on the bottom, that's a divide by 0 error. It's not possible to have a 0 on the bottom. So these next 4 are just asking you to find the domain. So if we follow those steps, that would be setting the bottom equal to 0. I don't care what the top is at all, because the top can be 0, the bottom just can't. And if we solve, we get x is equal to 1. So that means that my domain, if I put this down on a number line, I have an open circle here. I have shading to the left and right. So that means my domain would go from negative infinity to 1, and then 1 to infinity, because there's only one number there. So that's my answer for that one. The next one should have 2 answers because it's a y squared. So there should be 2 numbers that give us problems. So that'd be plus 8 minus 2 if you factored this correctly. And then that would be y equals negative 8, y equals 2. So in the end, we'd go from negative infinity to negative 8, negative 8 to 2, in union with 2 to infinity. So that would cover all of the number line except for negative 8 and 2. Number 3, if we divide by 5, we'd get y equals 0. So that'd be our only problem. So your domain would be from negative infinity to 0 in union 0 to infinity. And the last one, if you make it equal to 0 and you solve, you'd get negative 2 is your only problem. So now your number that you cannot use would be negative 2. So that'd be negative infinity to negative 2 in union with negative 2 to infinity. And that would be your domain. So that's the first third of your homework, is setting the bottom equal to 0 and solving and making sure that you find all of your numbers that would give you a divide by 0 error, and just delete those from your possibilities, because domain is your possible zeros. So if we keep moving around, moving down here, reducing now is next. That's our next third. Reducing just means that we're going to see what the factors are on the top and the bottom and cancel them. So it says, how would you reduce this fraction? Well, if we reduce this fraction without a calculator, and we did it by hand, I know that the top is 5 times 5, and the bottom is 5 times 7. That would equal 25 and 35. If we take a look at those, that numerator denominator, we can see that the 5s are identical, so you can cancel out one set of 5s. So that'd be 5 over 7 is your final answer. We're going to use that same concept when we go to reducing these rational functions that have binomials, trinomials on the top and bottom, to make sure that we're getting it down to the simplest form, just like this 25 over 35. So same idea here. Our first step is we're going to factor the top and the bottom, or the numerator denominator, as much as possible. So if we factor this, the top, I believe we can pull out a 3. The bottom, we can pull out a GCF of a 9. I think we can still factor some more here. I think that this would equal this trinomial multiples of negative 2 that had to give me 1. That would be a positive 2 and a negative 1. On the bottom, we have multiples of negative 3 that had to give me 2. That would be plus 3 and a minus 1. So everything's factored as much as possible. So that's step 1. We're going to do our canceling now. So cancel the common binomials. So let's see what we have for my binomials now. I think we have an x minus 1 on the top and bottom. And then step 3 is to simplify my monomials. Those are the things on the outside that we pulled out as a GCF. So if we simplify these monomials, I think 3 divided by 9 can simplify down to 1 over 3. So now I have, in the end, I have this x plus 2. I have a 3 and an x plus 3. You can't cancel these x's in the top and bottom because they're parts of other binomials. So that's always a mistake that people make, is they try to cancel out these x's. It's not possible. It's not allowed. And then when we're having these little dots right here, let's write down that part. Can't cancel pieces of binomials. So that's important. You can't cancel a part and a part. And that's good for that. All right, so let's do some examples here for reducing. So number 1, if we reduce, if we factor the top and bottom as much as possible, that means I'd pull out a GCF of a 5x up top. I'm left with x minus 2. On the bottom, I could pull out a 10. I'm left with an x minus 2. The x minus 2's will cancel. 5 divided by 10 can simplify to 1x over 2. So this would be my answer. Some people will ask, do you have to write the 1? No, you don't. I'd accept it as just x over 2 as well. Either way, it's good. Number 2, you can pull out a GCF of a 2x squared. And you're left with x squared plus x minus 12. And on the bottom, if you pull out a 4x, you're left with x squared plus 3x minus 4. I think you can factor both those trinomials again. So I'm going to do that. And what do we got? I think that's plus 4 minus 3. On the bottom, you have plus 4 and is it minus 1? So let's see here. Binomials wise, you can cancel the x plus 4's. Monomials on the outside, 2 divided by 4 can cancel into 1/2. 1x can cancel from the top and bottom. So you're still left with 1x because there was 2 to start. So now up top, we'd have in my answer x times x minus 3. On the bottom, we have a 2 times x minus 1. So this is just a lot of practice of factoring and seeing if you can figure out how to cancel correctly. For time, I'm going to skip 3. Well, I'll show it, but I'm not going to explain it. How about that? That way you can fast forward and see if you can do it. This is how you do it. Bang. This would be my answer. X plus 3 over x plus 4. All right, I want to get to 4 because that one has a 4-termer. Whenever you have 4 terms, that means you're supposed to group them. That's our first step. In my brain, I tried to pull out a GCF, and I couldn't, by the way. If you're wondering if I skipped that step, no, I did not. So the first 2, I could pull out a 2b, it looks like. And I'm left with a plus y. The next 2, I could pull out a 3, and I'm left with a plus y. On the bottom, oh, I got to finish that. So that'd be 2b plus 3, one of your factors. A plus y, because it shows up twice, is your other factor. All right, now on the bottom, I have a 2b and a 1b. And then the multiples of negative 15 that add to give me negative 7. 3 and 5. I want to say it's minus 5 plus 3. And I think that makes sense because I see a 2b plus 3 up top. Normally one of them will be in common at least. So now I see this 2b plus 3 on the top and the bottom. Those cancel. So I'm left with a plus y over b minus 5 in the end. I want to point out for number 3, you can't cancel these x's, by the way. So don't attempt to. You can't cancel pieces of binomials. All right, so that's all of the simplifying or reducing rational functions part that we have. Oh, that's it. That's all we got.